Hello, we are going to start with chapter 10, section 1. Please give me a minute. I'm going to present my screen. Yes, 10.1 deals with parametric equations. We know that the equation x squared plus y squared is equal to 1 is the equation of the unit circle, that is the circle with the center origin and a radius 1. This is an approximate sketch of that. Clearly, this equation does not represent a function y because it does not pass the vertical line test. The graph does not pass the vertical line test, so this is not a function. X and y may be expressed as a function of another variable t known by the name a parameter. T is a parameter. So, for example, in this particular case, if x is equal to cos t and y is equal to sin t, then x square plus y square is equal to cos square t plus sin square t, which is equal to 1. That's the Pythagorean identity from trigonometry. When t is equal to 0, x is cos 0, which is 1, and y is sin 0, that is 0. So the point xy is 1, 0. So the 1, 0 corresponds to t is equal to 0. When t is equal to, as t increases, the point xy moves along the circumference of the circle. When t is equal to pi over 2, point is 0, 1, because cos pi over 2 is 0 and sin pi over 2 is 1. And when t is equal to pi, the point xy is negative 1, 0, because cos pi is negative 1, sin pi is 0. When t is equal to 3 pi over 2, the point is 0, negative 1, because cosine of 3 pi over 2 is 0 and sine 3 pi over 2 is negative 1. When t is equal to 2 pi, the point again becomes 1, 0, because cosine 2 pi is 1 and sine 2 pi is 0. So that is the starting point. So the point when t is equal to 0, the point is at 0 at 1, 0. When t is equal to 0, the point is at 1, 0, and it moves along the circumference of the circle. It takes one complete revolution and come back to 1, 0 again when t is equal to 2 pi. So this equation, x is equal to cos t, y is equal to sin t, 0 less than or equal to t less than or equal to 2 pi, represents the parametric equation of the unit circle. In general, x is equal to ft and y is equal to gt. T lies between A and B, represents a parametric equation of a general curve. If the parametric equation of a curve is known, then we may draw the curve by preparing a table with the columns t, x, and y. Graph may be drawn by using the TI 83 or 83 plus. Keep the calculator in the parametric mode, then enter x and y by pressing y is equal to, then press the graph. So I'm going to show you how to do that. First, you keep the calculator in parametric form. Mode parameter is PAR. Good. Then you go to y is equal to, x is cos t, y is sin t, and we have to change the window from 0 to 2 pi is okay, but for x and y let us use -2 minimum. X maximum is 2, x scale is 1, y minimum is -2, y maximum is 2, and y scale is 1, and you graph it. Window range, some problem, window 0 to 2 pi, 0.1, -2 to 2, okay. Y minimum is -2. Y minimum is -2. Y maximum is 2. Y scale is 1. Hopefully that will be fine. So that is how you draw. And it doesn't look like a perfect circle. That is because of the window. So what you have to do is, if you want to see it as a perfect circle, then go to zoom z square number 5. So it looks like a perfect circle. Okay, now that is how you draw graph. And here we are going to start with the problems from the book. Starting from number 6, here is the question. Sketch the graph and indicate by an arrow the direction in which the curve is traced as t increases. Eliminate t to find the Cartesian equation. So the question is x is equal to 3t plus 2, y is equal to 2t plus 3. These two equations are linear. If it is linear, you need only 2 points. You don't need many points. You need only 2 points. So t is equal to 0. Suppose t is 0. When t is 0, substitute here x is equal to 3 times 0 plus 2, that is 2. Y is 2 times 0 plus 3, that is 3. So the point is 2, 3. Then when t is equal to 1, x is 3 times 1 plus 2, and y is 2 times 1 plus 3. So that is 5 and 5. X is 5, y is 5. Now you on the xy plane, this is the xy plane. When x is equal to 2, y is 3. When x is 2, y is 3. That corresponds to t is equal to 0. When x is equal to 5, 1, 2, 3, 4, 5, y is equal to 5. So I want to join the points and draw a line. As t increases, t is 0 here, t is 1 here. So t is increasing from left to right in this case. So draw a mark an arrow from left to right. That is the answer to the first part of the question. Now B part. B part, x is 3t plus 2. That means 3t is equal to x minus 2 by subtracting a 2. Divide both sides by 3. You get t is equal to x minus 2 over 3. And now y is 2t plus 3. That is y is equal to 2 times the value of t, that is x minus 2 over 3, plus 3. That is, distribute that 2, you get 2 over 3x minus 2 2s are 4, so minus 4 over 3 plus 3. We need a common denominator to add or subtract fractions, so multiply second number, that 3, by 3 over 3, which is a 1. So it becomes 2 over 3x minus 4 over 3 plus 9 over 3, because 3 times 3 is 9. 9 over 3 minus 4 over 3 is 5 plus 5 over 3. So the equation is y is equal to 2 over 3x plus 5 over 3. This is number 8 from the textbook. X is equal to sin t, y is equal to 1 minus cos t. T varies from 0 to 2 pi. X is equal to cos t. I wrote a y here, it is not y. X is equal to y is equal to 1 minus cos t. Y is not cos t, y is equal to 1 minus cos t. Please make that correction here. Implies y minus 1, you subtract a 1, it becomes y minus 1, it's equal to negative cos t. And so x square plus y minus 1 the whole square is sin square t plus negative cos t, the whole square, that is sine square t plus cos square t, which is equal to 1, trig identity. So x square plus y minus 1 the whole square is equal to 1. This is a circle with the center 0, 1 and radius 1. So this is a circle with the center 0, 1 and radius 1. Now let us see the direction. When t is equal to 0, x is sine 0, which is 0. Y is 1 minus cos 0, that is 1 minus 1, which is 0. So the point is 0, 0. And when x is t is pi over 2, x is sine pi over 2, that's 1. Y is 1 minus cos pi over 2, that is 1 minus 0, that is again 1. So that point is here. And then t is equal to pi, x is 0, y say cos sine pi is 0, y is 1 minus cos pi is negative 1, so that is 1 minus negative 1, which is equal to 2. So the point is here, and it comes back as t approaches 2 pi, it comes back to the origin. So that is the graph. Now question number 10. Question number 10 is x is equal to t square, y is equal to t cubed. The equations are not linear, so you have to use as many points as possible. Here I used t is equal to negative 2, negative 1, 0, 1 and 2. So minimum 5 points are required. When t is equal to negative 2, x is t square, that is 4, and y is t cubed, that is negative 8. When t is equal to negative 1, x is negative 1 the whole square, that is 1. Y is negative 1 cube, that is negative 1. When t is equal to 0, x is 0 square, that is 0. Y is 0 cubed, that is 0. When t is equal to 1, x is 1 square, that is 1. Y is 1 cubed, that is 1. When x is equal to 2, y is 2 square, that is 4. X is 4. I repeat. When t is equal to 2, x is 2 square, that is 4. Y is 2 cubed, that is 8. And now you draw this on the xy plane. On the x-axis, x varies from 0 to 4. I have marked only up to 4. And then y varies from negative 8 to positive 8. And so when x is equal to negative 2, no, t is equal to negative 2, x is equal to 4, y is negative 8, x is equal to 4, y is negative 8, x is equal to 2, 1, x is equal to 1, y is negative 1, x is equal to 0, y is 0, again x is 1, y is 1, x is 4, y is 8. So direction is from this point, and this is the direction. As t increases, the graph goes in that direction. Number 14. X is equal to e to the t, y is equal to e to the negative t. This means both x and y are positives. E to the t is always positive. E to the negative t is 2t is always positive. So x and y are positive means the graph is completely in the first quadrant, because x is positive, y is positive only in the first quadrant. And you start with y. Y is equal to e to the negative 2t, that is 1 over e to the 2t, that is 1 over e to the t the whole square, that is 1 over x square. Y is equal to 1 over x square. You may graph this, or you may graph this by using the parametric mode. So this will be a branch of the rectangular hyperbola in the first quadrant. As t increases, the graph goes in that direction, because t is equal to 0 means e to the 0, that is x is 1, y is 1, so this is t is equal to 0. When t is equal to 1, it is e 1 over 2e, so this is the direction. Okay, then number 16. X is equal to square root of t plus 1, y is equal to square root of t minus 1. Radical, they are under radical sign, so both x and y are positive. Okay, now square the first one. X is equal to square root of t plus 1 implies x square is equal to t plus 1, and that is t is equal to x square minus 1. Subtract a 1 here. Y is equal to square root of t minus 1 implies y is equal to square root of t. T is x square minus 1 minus 1. That is square root of x square minus 2. And so y is equal to square root of x square minus 2. Y is clearly positive, and since x square minus 2 is under radical sign, x square must be greater than or equal to 2. So this is the graph. Actually, the parabola, it is a parabola, but y is positive, so it is the upper half of the parabola, and the direction is given there. Number 18. X is equal to tan square t, y is equal to secant t, negative pi over 2, less than t, less than pi over t. We know secant square t is 1 plus tan square t. That's a trig identity. So y square, secant t is y, so y square is secant square t. Y square is 1 plus x, that is x is equal to y square minus 1. And when t is equal to negative pi over 2, x is tan square negative pi over 2, that is infinity. Y also is infinity, so it is coming from infinity. And when t is equal to 0, it is x is 0, y is 1. Secant 0 is 1 over cos 0, that is 1. So this point is 1. And again, as t increases from 0, it goes back to the infinity through the same curve. So that is the explanation here. X is tan square t, that is greater than 0. Since negative pi over 2 less than t less than pi over 2, cos t is positive, and therefore secant t is positive, because this is either in first quadrant or fourth quadrant. So secant t is positive, means x is positive and y is positive. And so the graph is in the first quadrant. When t is negative pi over 2, x is tan square negative pi over 2, which is infinity. Secant negative pi over 2 also is infinity, so it comes from infinity along that curve, that parabola, and then it reaches 0, 1, and then go back to infinity. Oh, number 20. Question number 20. X is equal to 2 plus sin t, y is equal to 1 plus 3 cos t, pi over 2 less than or equal to t less than or equal to 2 pi. X is equal to 2 plus sin t means sin t is equal to x minus 2. Y is equal to 1 plus 3 cos t means 3 cos t is y minus 1. So cos t is y minus 1 over 3. If this is a general direction, if cos t and sin t are present in the equation, then you isolate cos t and sin t and use the identity sin square t plus cos square t is equal to 1. So if sin t and cos t are present in x and y, you isolate them, isolate sin t, isolate cos t, and then use the identity sin square t plus cos square t is equal to 1. So here x is 2 plus sin t, so sin t is x minus 2. Y is 1 plus 3 cos t, so y minus 1 is 3 cos t, that is cos t is y minus 1 over 3. And sin square t plus cos square t is equal to 1 implies x minus 2 the whole square plus y minus 1 the whole square over 9 is equal to 1. This is an ellipse with the center 2, 1. Ellipse with the center 2, 1, and the major axis is parallel to the y-axis because the denominator of y term is bigger than that of the x term. So it is an ellipse with the center 2, 1. Major axis parallel to the y-axis. In fact, it is x is equal to 2. And now we are thinking about the direction. When t varies from pi over 2 to 2 pi. When t is equal to pi over 2, x is equal to 2 plus sine pi over 2, that is 2 plus 1, which is 3. And y is equal to 1 plus 3 times cos pi over 2, which is 0. That is, y is 1 plus 0, which is 1. So the particle starts at 3, 1. Particle starts at 3, 1. No, it's not exactly here, it is here. So there is a small correction there. It starts at this point, not 3, 0. It is at 3, 1. This is 1. So there is a minor mistake there. Please correct it. It starts at 3, 1. And moves along the ellipse. T is equal to pi. X is 2 plus sine pi, which is sine pi is 0, 2. And y is 1 plus 3 cos pi. Cos pi is negative 1. So that is negative 2. So it becomes 1 negative 2. It is here. And then when t is equal to 2 pi, x is 2 and y is 4, you substitute. X is 2 because 2 sine pi is 0 and cos pi is 1. So it is 1 plus 3, 4, and reaches at the top of that ellipse. So it starts from 3, 1 and then moves along the ellipse and it reaches at the top vertex of the ellipse. Number 22. X is sine t, y is cos square t, negative 2 pi less than or equal to t less than or equal to 2 pi. Okay, x is sine t, y is cos square t. So x square plus y is sine square t plus cos square t, that is 1. That is x square plus y is equal to 1 means y is equal to 1 minus x square and y is positive. So it is the upper part of the parabola. So the parabola looks like this. It is the upper part of the parabola because y is positive. And the path is a parabola with vertex 0, 1 above the x-axis. Now the interesting fact is you prepare a table like this. When t is negative 2 pi, negative 3 pi over 2, negative pi over 2, etc. And then find the corresponding values. First you get 0, 1, it starts here. And then it goes to 1, 0, that is here. Then it comes back, again it comes here, again it comes back, and it repeats several times. The particle starts at 0, 1, moves to 1, 0 along the parabola, returns to 1, 0, 1 along the curve, then goes to negative 1, 0, and returns to 1, 0 along the curve, again goes to negative 1, 0, then back to 1, 0 along the curve. You may use your calculator to verify this answer and keep the calculator in the parametric mode. Yes, now y is equal to sine t. No, yeah, x is sine t, y is cos square t, cos t square, and you have to set the window. Window is from negative 2 pi to 2 pi. Negative 2 pi to 2 pi, and okay, let us see the graph. Yes, again back, again comes up. So that is the graph, and if you want to see this table, first you table set, negative 2 pi. Start with the negative 2 pi. And delta means pi over 2. Okay, now you graph. Now if you want to see the table, look at the second table. Second table. Okay, you have the values there. So it starts from 0, 1, and then go back to 1, 0, etc., etc. So this is the table there. So it starts from 0, 1, and then 1, 0, negative 1, 0, and so on. So that is how you graph it, and that is the end of 10.1.